All right, let's jump right in. When you think about the global energy revolution, what comes to mind? Giant solar farms? Huge wind turbines? Well, the real heart of it all, it's something much quieter. A single piece of tech, a mix of hardware and software that's shaping up to be maybe the most important invention of our time.
Now, you've probably seen one company's name pop up a lot with this stuff, but trust me, the story is way bigger than that. The source material we're looking at today puts it in a really cool way. It says that in this grand symphony of green energy, there's one silent conductor keeping everything in tune. Because yeah, this isn't just about a brand war. We're talking about a fundamental shift, a whole new way of managing electricity for the entire planet. It's a technology that's, and I'm not exaggerating here, rewriting the very rules of how the grid works. So what is this thing? And why does it matter so much? Okay, so before we get to the solution, we've got to understand the problem it's solving. And honestly, it's a massive problem. Here's the crazy part. The more we switch to clean energy, like solar and wind, the more we're actually making our electric grid, well, unstable. It's this huge paradox at the heart of the green transition. So check this out. This really breaks it down. On the left, you have the old school grid. For like 100 years, it relied on something called mechanical inertia. Just picture these enormous, heavy turbines spinning in a coal plant. They're like giant, heavy flywheels. That physical weight, that momentum, kept the grid stable. It was a built-in shock absorber. But now, look at the right. That's our future. Solar panels, wind turbines, they don't have those big spinning parts. They connect with electronics. So as we swap out all that heavy spinning metal for sleek silicon, we lose that natural stability. The grid gets flimsy, fragile, and that's a huge risk. So think of it this way. The old grid had this big, strong, steady mechanical heart. The new renewable grid, its pulses all over the place. It's erratic. So what do you do when a heart has an irregular beat? You give it a pacemaker, and that's exactly what this technology is, a digital heartbeat for the planet's grid. And this is it. This is the magic box, the grid-forming inverter. Don't let the name fool you. It's not just some random part. It's the brain of a giant battery system. You see, old inverters were followers. They just listened to the grid's frequency and matched it. But these new grid-forming inverters, they're leaders. They create the beat. They use incredibly smart software to act like one of those giant spinning turbines, giving us something called digital inertia. So how does this digital inertia actually work? Well, it's basically a three-step process. First, it creates the beat. It sets a perfect, rock-solid frequency and tells the rest of the grid, hey, follow me. Second, it acts like a digital shock absorber. If the grid starts to wobble, maybe a big cloud blocks the sun, it instantly shoots out or sucks in power to smooth things out. And third, and this is the really wild part, it can heal the grid. It can do what's called a black start, basically rebooting an entire grid after a total blackout. That used to be something only a massive power plant could do. And look, this isn't science fiction. It's happening right now. In Hawaii, a huge power plant went down, and one of these battery systems jumped in so fast it prevented a massive blackout. And in Australia, the Hornsdale battery famously reacted to a coal plant failure in under 200 milliseconds. I mean, that's faster than you can blink. It's faster than any old-school mechanical system could ever hope to be. This is the tech that turns sometimes on solar and wind into always-on, reliable power. So whenever a technology this powerful comes along, what happens next? A gold rush. Or in this case, an oil rush. The global scramble to dominate the big battery market, it's the new great game. People are starting to call the prize digital oil. And this chart, wow, it gives you a real lay of the land. You see Tesla there, a huge name, with about 15% of the market, and right on their heels is Sungrow. But zoom out. Look at the real story here. When you group all the major Chinese players together, they are absolutely dominating the field right now. It's a massive lead. The race is well and truly on. Let's meet the players. First up, CATL. Think of them as the manufacturing empire. They are the world's biggest battery maker, period. Their advantage isn't just tech, it's pure mind-boggling scale. Next is Sungrow. A lot of folks see them as Tesla's #1 rival. Their specialty? The inverters, the brains of the operation. They're known for being absolute experts and for getting projects built incredibly fast. Then you've got BYD. You might know them for their cars. They're the biggest EV maker in the world. But they are using that expertise, especially their famous Blade battery, to push hard into energy storage, especially in new markets. And on the Western side, the main challenger is Fluence. This is a joint venture of giants, Siemens and AES. They have a deep background in the traditional energy world, which gives them a huge reputation for reliability, especially in places like the US and Europe where there are a ton of regulations. So what does the future of this race look like? Well, the projections here tell a really interesting story. Tesla is expected to hold its slice of the pie, mostly because of its brand power and software. The Chinese bloc is forecast to stay in the lead thanks to their price advantage, but they might run into some political issues. And look at the Western bloc. It's projected to grow a lot. It's getting a big boost from policies that favor local manufacturing. The whole energy map is literally shifting before our eyes. And this goes way beyond which company sells the most boxes. This is about geopolitics. It's redrawing the entire global energy map. The move from oil to electrons isn't just a tech shift, it's creating a whole new world of power politics. Just look at the contrast here. The 20th century, it was all about controlling physical spots on a map, like the Strait of Hormuz, where oil tankers had to pass. The 21st century, it's about controlling supply chains for things like lithium and cobalt. Forget OPEC. The new alliances will be built around energy storage. The currency of power isn't a barrel of oil anymore. It's a terawatt of electricity. And more importantly, the software that tells it where to go. So every major global player is making their move. China's strategy is to be the world's battery factory, dominating the raw materials and manufacturing. The US is playing to its strengths, betting it can be the software superpower that writes the code for the new grid. Europe, after the shock of its dependence on Russian gas, is trying to build a green fortress, total energy independence. And then there's India, which is in a fascinating position to become a swing producer, a key balancing power in this new world. Okay, so when you piece all of this together, the tech, the business, the politics, you start to see the outline of something huge, a truly mind-blowing vision for the future. We're not just talking about a better grid, we're talking about an energy internet. A network that wraps around the entire planet, sharing clean power. A world literally running on sunlight. Let's take a quick trip around the world to see what this actually looks like. First stop, the Sahara. There are massive projects in the works to connect the world's biggest desert to Europe with giant undersea cables, basically turning all that sun into power for a whole continent. Then over to India. In the Thar desert, they're building the foundation for what could be the world's first nation to run entirely on solar power 24/7, using enormous batteries to store daytime sun for nighttime power. And back in the US, the deserts of the Southwest are becoming the new Silicon Valley, but for sunlight. This is where the clean energy to power America's future is being generated and stored. It really all boils down to this. The 20th century was ruled by whoever controlled the oil fields. But the 21st century, it's going to be ruled by whoever controls the batteries and the brains that make the grid work. The last century was powered by combustion, by fire. The 21st century is going to be powered by intelligence, by code. So the ultimate question has changed. It's not who controls the fuel anymore, because the fuel is sunlight, and that's free for everyone. The real question, the one that will define our future, is who writes the code.